Hello friends, welcome to our YouTube channel Maths Olympiad by Subbarao. Today our topic is inverse of matrix. Inverse of matrix is a part of operation of matrix. This inverse of matrix denoted by A inverse. Next, A inverse is equal to adjoint of A divided by determinant of A. This is the inverse of matrix formula. A inverse is equal to adjoint of A divided by determinant of A. To know the A inverse, we must know the adjoint of A, number 1, determinant of A, number 2. When we know the adjoint of A and determinant of A, it is easy to solve A inverse. That is adjoint of A by determinant of A. Next, from the given matrix, to find the inverse matrices, there are two conditions. Number 1, it must be a square matrix. It must be a square matrix. Number 2, its determinant is not equal to 0. Its determinant is not equal to 0. Next, let matrix A is equal to A, B, C, D. Then A inverse is equal to A, B, C, D inverse. A inverse is equal to adjoint A by determinant of A. Next, in the A matrix, diagonal elements are reversed in the adjoint matrix. In the A matrix, diagonal elements are reversed in adjoining matrix. This is AD. Here it became the DA. Next, number 2, in the given A matrix, other diagonal signs has been changed in adjoint matrix. In the given matrix, other diagonal element signs has been changed in the adjoint matrix. Reversed means here it is plus B plus C. Here it is minus B minus C. Next, determinant of A. Determinant of A means it is cross multiplication. First main diagonal minus other diagonal. A into D, AD minus B into C, BC. Next, A inverse is equal to adjoint of A by determinant of A. Adjoint of A by determinant of A. Of course, since it is a second order matrix, that is 2 by 2 matrix, it is very easy to find the A inverse. If it is third order matrix, that is 3 by 3 or 4 by 4, it is more complicated. Next, if it is 3 by 3 or it's more, then given matrix divide into minor of the matrix. Minor of the matrix with the same order to find the adjoint of matrix. Next, how to draw the minor of matrix or submatrix from given matrix. We are dividing into the minor matrix. So that is submatrix. For A1, this is the submatrix. That is minor. B2, C2, B3, C3. For A1. For A1, this is the minor of matrix. B2, C2, B3, C3. For A1, B2, C2, B3, C3 is the minor of the matrix. So this minor of the matrix became the second order matrix. Now easy to find the determinant. B2, C3 minus C2, B3. Next, in the B1 also, for the B1, these both are the minor of the matrix. For C1, these both are the minor of the matrix. Similarly, for A2, B1 C1, B3 C3. B2, A1 A3, C1 C3. C2, A1 B1, A3 B3. These minors of the matrix of third order is became the third order of adjoining matrix. Third order of adjoining matrix. For one element, one minor. For one element, other minor. For other element, other minor. So that means here it is 9 elements, 3 by 3 order. We may get the 9 minors. We may get the 9 minors. Next, minor of A1, that is submatrix of A1. A1 means in the rows, it is first one. In the column, it is first one. So that means 1, 1. 1, 1. I can say minor of A1 is equal to minor of 1, 1. Minor of A1 is equal to minor of 1, 1. Similarly, for B1, minor of B1 is equal to minor of 1, 2. Why? Because of first row, second column. First row, second column. Similarly, here C1, first row, third column. So C1 is minor of 1, 3. That is minor of 1, 3 means M1, 3. Next, minor of A1 is equal to B2, C3 minus C2, B3. Minor of A1 is equal to B2, C3 minus C2, B3. Next, minor of A1 is denoted by M11. Minor of A1 is denoted by M11. Therefore, M11 is equal to B2, C3 minus C2, B3. Next, minor of B1 is equal to C2, A3 minus A2, C3. C2, A3 minus A2, C3. That is equal to M12. M12 means minor of B1. That is first row, second column. Row and column. Next, minor of C1 means A2, B3, B2, A3. Minor of C1 is equal to A2, B3 minus B2, A3. That is M13. Similarly, for others also. Next, for each element have the 1, 1 minor. Here 9 elements, minors also 9. Therefore, adjoint of A is equal to M11, M12, M13, M21, M22, M23, M31, M32, M33. This is third order matrix. Given matrix also third order matrix. Adjoint A matrix also third order matrix. Okay friends, repeating again, inverse of a matrix is obtained by dividing the adjoint of the given matrix by the determinant of the given matrix. Next, inverse matrix obtained dividing the adjoint matrix by determinant of given matrix. This is the formula. Next, to solve the inverse matrix, there are two conditions. Number one, it is a square matrix. Number two, its determinant is not equal to 0. Let A is equal to ABCD. Then A inverse is equal to ABCD inverse. As per this A inverse formula, adjoint A by determinant of A. Determinant of A means AD minus BC. Cross multiplication. This is the determinant of A. What about adjoint of A? Adjoint of A is equal to main diagonal of given matrix is reversed in the adjoint matrix. Here AD, it is reversed DA. And other diagonal Signs has been changed in adjoining matrix. Here plus B plus C minus B minus C. So this is the adjoining matrix. Adjoining matrix divided by determinant of matrix. We get the inverse matrix. Get the inverse matrix. Of course, it is a second order matrix. It is easy to find the A inverse. But what about third order matrix and fourth order matrix? It is more complicated. Too easy to solve that complicated matrix also. These matrices are divided into minor matrix. This matrix divided into minor of the matrices. Next, minor of the matrix. How to find the minor of the matrix? Let A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. This is third order matrix. 3 by 3. 3 by 3 means here it is 9 elements. Each element have the one minor. Each element have the one minor of matrix. How? Minor matrix for A1 is equal to A1 have in the first row and first column. You leave the first row and first column. What is left over? B2, C2, B3, C3. So this is the minor of A1. This is the minor matrix of element A1. B2, C2, B3, C3 is the minor matrix of element A1. Element A1. First row, first column. Minor of A1 is equal to M11. Next, its determinant is, this minor determinant is B2, C3 minus C2, B3. B2, C3 minus C2, B3. Therefore, M11 is equal to B2, C3 minus C2, B3. Next, M12. M12 means first row, second column. First row, second column. That is B1. Minor matrix of B1 element is equal to, you leave it first row, then second column. Then what is left over? C2, C3, A2, A3. That is C2, A3 minus A2, C3. C2, A3 minus A2, C3. That is minor of B1, M12. Similarly, minor matrix of C1 element. Then first row and third column, leave it. So this is the minor matrix of element C1. A2, B3 minus B2, A3. A2, B3 minus B2, A3. This is M13. That is 1, 3. First row and third column. Similarly, for other elements also have the minors. Similarly, other elements also have the minors. Then adjoint A is equal to element A1 minor is M11. Element B1 minor is M12. Element C1 minor is M13. Similarly, for others also, M21, M22, M23, M31, M32, M33. So this is the adjoint of A matrix. Matrix A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. This is third order matrix. Then adjoint matrix is equal to M11, M12, M13, M21, M22, M23, M31, M32, M33. Next, A inverse is equal to adjoint of A by determinant of A. Through this minor matrix of A, we may get the adjoint of A matrix. Then find the determinant. Adjoint of A by determinant of A, you may get the A inverse. Okay friends, thank you for watching this video. If you are interested, kindly like, subscribe, share your friends group, ask them to subscribe such more practice videos. Thank you very much.